For your 60-second writing, you should have come up with the 3 major rock types, given an example or characteristics of each rock type, and you can look at the box of rocks on your table and maybe identify those. I'm not going to go over this right now because this is what we're going to talk about in class today. So as we do our notes on rock types, in the past I've actually handed out a worksheet type thing that looks like this. If you want to, I can put this on Edmodo. This would be one way that you could take your notes if you want to. Put them kind of like in a table. So rock type, describe and define, how is it formed, where is it found, and examples. Okay? Yeah, kind of. Or yeah, exactly. That's one way you could do it. I'm just going to do it in, regular sections, but that's okay too. So we shall start at the beginning here with igneous rock. So the first rock type, we talked about it a little bit yesterday, and I think really the easiest one to understand and remember is igneous rock. So who can tell me something about igneous rock? Igneous rock is what? Exactly. Igneous rock is formed in volcanic areas from magma or lava. Now, what's the difference between magma and lava? Yes. Yeah, which is which? Lava is on the surface, so melted rock on the surface of the earth, and magma is underground. And we're going to talk about this because they're going to form different types of rocks because of how quickly or slowly they cool. So magma is melted rock under the ground, and lava is melted rock on the surface. Magma, so when you read in your textbook yesterday, igneous rock can be divided into intrusive and extrusive. Intrusive because it cools inside the crust. Intrusive, inside. Intrusive magma, it cools very slowly underground. It forms in the crust. The more slowly it cools, the larger the crystals. And one example of this is granite. And I'm sure all of you in your box have a sample of granite. And so you can see if it has small crystals, it cooled more quickly. And if it has larger crystals, it cooled very slowly, giving it a chance for those crystals to grow. Okay, so you've all looked at granite samples. And again, we've talked about this before, but the granite samples can be very different. Some of them are very pink. Some of them have a lot of white. Some of them are black, gray. And that has to do with what minerals make up the granite. And granite is an excellent example of all different minerals in one rock. Other examples of igneous rock include basalt, which is in the ocean crust. It's generally very black. It looks a little bit like granite, except it's very black. Then, no, see, it is. Basalt, that's what I thought. This basalt is an extrusive rock because it's on the ocean floor. Even though it says ocean crust, it's on the surface of the crust. So, lava rock is extrusive. It has exited the crust. Extrusive, exit. It cools on the surface, and it cools much more quickly. Just how quickly it cools depends on where it cools. And how quickly it cools makes a different type of rock or a different texture. There are some Hawaiian rocks. Obviously, somebody yesterday in one of the classes brought up, okay, well, Hawaii is a volcanic island. Does that mean that's a lot of igneous rock? Yes. And there's so much igneous rock that some of the names for rock types that we actually use are Hawaiian words, like this one, Pahoehoe, and this one, A'a. Now, I actually have some examples of these that I want to show you. But basically, the Pahoehoe is ropey. It looks like cooled taffy or stretched out caramel. Somebody has the Pahoehoe rock in their, I think it's you guys back there. Pick up that big rock there. Yes, take a look at that. So look at it and then pass it around. See how that looks like ropey? So you can see on the bottom that there's air bubbles in it, but you can see how it was flowing. And that rock, interestingly enough, I did not pick up in Hawaii. I picked that up actually in Buena Vista, which is a little weird, but um, that one. So Pahoehoe has this ropey, and it looks, you could almost see it flowing. We'll look at some more pictures of it. But that's the Pahoehoe. A'a has higher silica, and so it's thicker. It doesn't flow, and so as it flows, it makes little pointy, pokey parts. And so it's called A'a, which you can imagine, yes, exactly, is this sound when you are walking on top of it wearing nothing but flip-flops, or slippers, as the Hawaiians call them. Then there's lava rock or pumice, has lots of air holes. Sometimes it floats. It's also sometimes called scoria. We always called it lava rock. Everybody has one of these in their box. They used to use these like as a roofing material. They'd put this on the roofs of the houses. Obviously here in Colorado, where you get a lot of wind, putting light rocks on the roof is not great. But this cooled very quickly, and because it cooled quickly, the air bubbles expanded and made bubbles in it. So this is a very easy to identify lava rock or scoria. Pumice is similar, only pumice is usually whitish or gray colored, and there's not a pumice sample in here. You'll see a pumice sample in your lab tomorrow. And then basalt is that fine-grained. It forms on the ocean floor. It looks more like granite. It's generally black or very dark gray. So those are some of your igneous rocks. So you've got igneous rocks, you've got how it's formed, where it's formed, some examples of it. What are igneous rocks used for? They talked about this in the textbook. Yes. Building materials, specifically which one of these fabulous ones is used for granite? Yes. Granite, as we know, it's very hard. It's actually kind of pretty too, but granite is used in making buildings, like granite blocks. Granite now is used as a material for countertops and stuff like that. It looks very pretty when you polish it. Yes, what else? Excellent. So tools in cleaning, pumice rock can be used almost like a sandpaper type thing. Every single one of you has a piece of obsidian, which is also known as volcanic glass. This is very pretty, very shiny. Um, and this has a very distinctive look and shape to it. And if you look, remember with minerals we talked about fracture and cleavage. This has a conical flat fracture. And you can see that it would be easy. People made blades, knives and stuff out of obsidian because you can get a very, very sharp edge. And you do actually have to be careful because you can actually cut yourself on the edges of the obsidian rocks. So that's volcanic glass, also a volcanic rock. I think it would be too brittle, but I don't know to make countertops out of it. All right. Any questions about the volcanic rock? Next we have sedimentary rock. Sedimentary rock. Now here in Colorado, jumping back to the igneous rock, we have a lot of granite. But we also, in Colorado, have a lot of sedimentary rock. Sedimentary rock is rock that is formed in layers, and layers of sediment. Let's do this here. Do this one at a time. So sediments are just bits of eroded rock or soil. Sometimes there's fossils. If you find fossils in the rock, it is sedimentary rock. This is going to, so rock, soil, sometimes living things, sand, mud. So these are the types of rocks that are going to have maybe shells in them. It's going to include sandstone, which we have a lot of here. Coal is a sedimentary rock. And so you get these layers that are deposited through erosion and deposition, which we'll talk about. And then they're compressed over time. They're compressed because they're buried in the weight of the other rocks um, compresses them. Or sometimes chemical processes can make them into layers too. Sometimes you can actually see stripy layers on the rock. Sometimes you can see or feel that. And then other times you can just see it feels like sandpaper, has a texture like sandpaper. They classify it by the type of sediment, pretty obvious sort of stuff. Mud and fine sediments would be actually shale or mudstone. Oil shale is where we get natural gas and oil deposits from oil shale. We have a lot of that in our state. You sometimes just call it mudstone. Sandstone and limestone. Limestone is generally more whitish. It has calcium from shells. Sandstone, here in Colorado, here in this area, we have the lion sandstone that is used in a lot of buildings. So all the buildings at CU have that flagstone or lion sandstone. There's samples of that in your box. And then you could have something called conglomerate. Conglomerate just means a bunch of things stuck together. And conglomerate rock looks like concrete. It's very poorly sorted. You've got big rocks and small rocks and sand and mud and gravel all sorted in together and solidified into rock. And so conglomerate is actually, concrete is a type of conglomerate rock, um, though it's man-made. And then coal, as we talked about. So write this down, but then take a look in your box for types of sedimentary rock. Sedimentary rock forms in the bottoms of ponds and lakes and oceans and deserts. It can tell us about past climate because of the fossils. It can tell us about past climate because what it's made of. If you have a lot of sandstone, it could be that the area was a beach or desert. If you have ripple marks that get fossilized in, obviously that tells you there was water. Poorly sorted things with lots of like big rocks and small rocks indicates there was fast moving water, like flooding. Um, Coal tells you that there was organic material, so usually like swampy, jungly kind of areas that gets compressed into coal. Same thing with the shale and mudstone, or the shale that we get oil out of. Obviously, there's was living things there, so that we can get the oil and natural gas out of that. So take a minute and write this stuff down and find your sedimentary samples in your box. Um, but it's something important about the rocks. The town of Morrison is named for the rock that is in Morrison, the Morrison sandstone. And that is the layer, that is a layer that very commonly has dinosaur fossils. Okay. The Flatirons in Boulder, the rocks around Red Rocks, all of that is actually sedimentary rock. Sedimentary rock that was originally laid down horizontally, that through other processes has been tipped up. So the Flatirons are sedimentary rock, rocks at Red Rocks are sedimentary rock. All the beautiful rock formations in Utah, sedimentary rock. Okay, and now our third rock type. Our third rock type is metamorphic rock. Metamorphic rock. And metamorphic rock is changed or morphed, like the Mighty Morphin Power Rangers, right? Metamorphosis, like a butterfly. Metamorphic rock. So it is rocks that started out as one of the other rock types and was changed by extreme heat or pressure. So metamorphic rock, it could be, so marble used to be sandstone. All of you have a sample of marble in your box. And if you look at the sample of marble, it looks a lot like sandstone, except it's a little bit sparklier and more crystally and smooth and hard. So it used to be sandstone, but through extreme heat and pressure has been changed chemically so that it is no longer the same chemical makeup. So marble is a very common metamorphic rock. Slate. Slate used to be shale. What is slate used for? Does anyone know? Slate, like chalkboards. You can also use slate for tile, for floors. And then gneiss or schist used to be granite, and I couldn't find my samples of this, but basically granite is going to look like this, right? With its different crystals. So your sample of granite looks like this. Then through extreme heat and pressure, it can actually be kind of crushed, and then it looks, I think it looks kind of like, you know, fudge ripple ice cream. And you'll find in gravel, you'll find a lot of rock like this. And so it looks like this. It used to be granite, and it's been changed to schist or gneiss. So it's banded or folded, or one of the words they use is foliated. So it has that that almost layered look, but it's not a sandstone. Metamorphic rock, Tim and Roby were talking about this yesterday in the Brain Pop, extreme heat and pressure. It's not enough to melt it. It doesn't melt it into magma, otherwise it would turn it back into igneous rock. But it is enough to bake it, to cook it. So if you look, say here's a volcano, here's the magma chamber. This here is melted magma, will become a volcanic rock. But around the edges here, this is not melted, but it gets really, really hot and it chemically changes the rock. So in volcanic areas, you're going to have some metamorphic rock near the igneous rock. You can also have, in another week or two, we're going to talk about plate tectonics and the fact that the plates of the earth move and crush into each other. So there can be extreme pressure, either from being buried deep in the ground or from being crushed and squished together. And so then you get changes like this. So in your box, the marble is obviously a metamorphic rock. You might have a rock that looks a little bit like slate. And then a couple of you have, I know that box back there, if it looks kind of sparkly, shiny, minerally, it's probably a metamorphic rock. Or if it has that look like chert, that clear look, then it might be a metamorphic rock. So rocks that have gone through change. I'll let you do that for a minute, and then we'll come back and talk about what it's used for. All right, and so for marble, as we were just talking about, marble is used in building materials. Marble can be polished and they make countertops out of that as well. Has a very different look than the granite. Shale can, or excuse me, slate can be used for for tile or countertop. Nah, not for countertop. Usually it doesn't have that highly polished thing. Um, both marble and granite can be used for like gravestones, headstones. Which one do you think lasts longer, marble or granite? Generally, the granite lasts longer. One of the things with the marble, sometimes it's marble used to be either limestone or sandstone, and if it was limestone, then it tends to react to water, to acid rain. The limestone reacts to like vinegar water type stuff, only obviously not super fizzy. But so marble heads grave markers tend to erode more, but they start out as that pretty white color. So many monuments and statues and stuff are made of granite or marble. The marble is a little bit softer for sculpting. A lot of the famous Renaissance sculptures. There's famous marble quarries in Italy that they cut the marble from for that. Okay, and then finally, the last thing, the rock cycle. The rock cycle is basically how rocks form and how rocks change from one form to another. The Earth itself is about 4.6 billion years old, but the oldest rocks we found are only about 3 billion years old. And the reason why is because rocks are constantly changing. So this picture is in your textbook, but you should kind of make it now. So we've got the three rock types, igneous, and we'll do metamorphic, and sedimentary. And then we're going to talk about how each one can change or break down or turn into one of the other types. So igneous, sedimentary, and metamorphic. So who knows what's one of the ways rocks might change in the rock cycle? Well, first of all, yes. Excellent. And extreme heat and pressure are going to make which type of rock? Metamorphic. That's kind of the lamest arrow in the world. Okay, so you're going to make yours so you can actually read it. Extreme heat and pressure can turn either igneous rock into metamorphic or sedimentary rock into metamorphic. Okay, how can either type of rock turn back into igneous rock? It gets so hot it melts. We're just about out of time, so please make sure you have this written down. So it'll actually melt into igneous. Now here's the tricky question. How are these rocks going to turn into sedimentary rock? What's sedimentary rock made of? Little particles, sand, rocks, dirt, mud. So what's going to happen to these rocks to turn them into sedimentary? Erosion, right? So wind and water are going to cause erosion to break it into small particles. So in the Earth's crust, these things are constantly happening. Rocks are constantly breaking down and then reforming. Like I said, the picture in the textbook's better, but that's the basic concept. Rocks are constantly changing from one form to another. Questions about any of this? Gonna take an